So first, find the file of interest for you. So let me actually find an NMR file. I'm just gonna open ethyl acetate. Okay, so once you've opened your file, you may see that sometimes your scale is a little bit off in terms of numbers. There's a way of cutting that, but it's this one's not too bad because it goes up to 14. But if you saw like the proton NMR going all the way up to like 30 or something like that, there's a way of clipping it. And the way that you would do that is there's a little under view, there is a little scissors looking thing. I'm going to do this right here just so that you can see. It's not necessary because it's not that far. And when you click and drag, you get rid of it. Now, the other thing is for this sample, I know I use chloroform D as my solvent, and I also had TMS in it. So if I zoom in right here, you'll see a little tiny peak right here that shows up a little bit smaller than 0, and it really should be at 0. So when I go under analysis, I can click on reference, and I'm going to click on reference, and it should bring up a little table once I click on the peak. And I want to tell it where that peak should be. So I know this is TMS. I'm going to look for TMS in my list. If I knew what number it should be, I could actually write it in, but I'm just going to use what's in here, and I'm going to do that. And then I'm going to this little button right here, or if you go to view, it's the same button as right here. This allows us to go to the full spectra. And so if I zoom back into my, well, let me undo what I just did because I clearly did something a little bit wrong somewhere. So this should have been 0. This should be coming out to 0. And when I zoom back out, we should now see that peak at 0. So there we go. And then it shows me 0 TMS at the top. So it's my way of calibrating my scale. Now, I'm going to go back to the rest of my spectra. This little peak here is my chloroform D, and I don't need to label it or anything like that, but I'm going to go and put my mouse over it so you can see there's a value when you put your mouse over it under the little peak picking, and that's this little button. It looks like a hand and it's touching the peak. Now, do not use the auto peaking or the auto integration or anything like that, because it will do some weird things and pick up on things that shouldn't. We want to do this manually. Now, this is ethyl acetate. And if you want to go back and look at what your structure of ethyl acetate is, you can, but it has an ethyl group, and then it has a methyl group right next to an oxygen. Right next to a carbonyl, and then it has a CH2 right next to an oxygen, so you would expect it to be pretty downfield. So on another page, I'm going to actually draw it so you can see it, so we can see what that looks like. So I'm going to go to molecule, and I'm going to draw ethyl acetate. So I expect this to be a singlet, And then there's an oxygen right here attached to a CH2 and then a CH3. So this should be a singlet right here. This should have this has no hydrogen, so it shouldn't show up on a proton NMR. And then this is a CH2, but it's right next to an oxygen, so it should be pretty far downfield, like close to 3.5 to 4-ish. And then this is a CH3 next to that CH2. So this CH3 is going to cause this to be a quartet. This CH2 is going to cause this to be a triplet. So when we look at our signals, we do see that singlet for that CH3 next to the carbonyl. We do see a triplet here that's more upfield away from the oxygen and a nice little quartet. So this is a perfect NMR. Actually, this NMR was run on a much stronger NMR. So it's a very, very, very beautiful looking NMR. So what I'm going to do is I'm going to do my peak picking. So if I click on this, that's a singlet at 2.05, and I expect that to be roughly around there. And then I have a triplet at 1.26, and then I have a quartet that's somewhere between 409 and 413. But now I want to do my integrations. The problem with integrations is that we have to see exactly where we're integrating. And so we would take our little finger pointer and manual, and you would click and drag from one side of the peak to the next. And it's going to set it to 1. But I know that triplet really represents 3 hydrogens. So I'm going to edit that integral. I'm going to normalize it to 3, apply, so that when I integrate everybody else, I should see the right integration. So this should have also be a singlet that integrates for 3 because it's a CH3. So I'm going to do this. And see, it comes out to 2.9, which is about 3. It depends on how perfect integrated, and that's why we want to zoom in, because by zooming in, you get it to be better. If you don't zoom in, it's a little hard to do this. So here I have a triplet. I'm going to integrate this, and so this, sorry, a quartet. This quartet is supposed to come out to being 2, and we see it's about 1.98, which is about 2. So when I zoom out of here, I see I have those values. Now I have my integration, I have my shifts, and I know my multiplicities. Now, one of the reasons that I like this software over many other types of software that are available for NMR is we can do a NMR analysis of our peaks. And so what's going to happen here is that because, and this is why I did this way so I could show you this, because when I clicked on this, I only clicked on 2 peaks, it thinks that this is a doublet. So if I wanted to tell it that this is a quartet in this one peak, I need to actually pick each peak in there. And so when I report this, I can report this as a range instead of telling it the whole thing. And so it comes out now, this shows up as a quartet. So I'm going to zoom back out. Now for carbon NMR doesn't have multiplicities. It's just our peak picking. So you don't need to do this part. So I am going to put all the peak numbers in here. And so it changes this to triplet. Okay, so this being a triplet between 1.24 and 1.29. And there's another great thing about this is, so now you can see that those values are here. So one of the things that I can do is I can click on this little thing that says report multiplets, And when I click on it, I actually see everything showing up right here, including the J values. So the J values tell us what couples. So here you can see that that quartet has the same J value as the triplet, and that's because they're coupling with each other. Those hydrogens are coupling with each other, so we expect them to be the same. So I could then just take this and I can copy this into my lab notebook. So copy, and then go to my lab notebook and paste that in. So remember in your previous examples, you had to manually write all of them in. Voila, you don't have to do that. You could just put your information in just like that. And then for carbon NMR, you would do the exact same thing, except there's no multiplicity. So you just click on the peak. And so when you click on the multiplet analysis, what ends up happening is that there's no quartets or triplets. It's just the numbers. So again, you just copy and paste that, and it's in the right order. Now, if you weren't sure it's going to show up in the right order, you would right click on properties and you would make sure that it's in the Journal of American Chemical Society format, which, or some of these other formats are identical, but Journal of American Chemical Society format is how we want these to come out, because that's the formatting that you have here. So that's pretty much all there is to your what you need to do. So just follow this step by step. So again, play it back, stop and pause, and then do the same thing.